Greetings, ladies and gentlemen, and welcome to lesson 1.3, page 16 in your Big Ideas book. We're continuing on our unit of integers, and today we're going to apply what we learned to subtract integers. We are going to subtract integers. The thing is, we're going to subtract integers by changing to an addition problem and then adding. So if yesterday you were comfortable and you feel confident with adding these integers, then subtracting is going to be pretty straightforward once you learn, hey, when I look at that operation, it says subtraction. Before I do anything else, I'm going to change it to addition, and then I'm going to do the addition. How cool is that? Our essential question, ladies and gentlemen, how are adding integers and subtracting integers related? Now, I know being a person of character and intelligence, you went to the book and you wrote down those notes from the book first so that you have an idea of what we're going to be doing. And of course, right straight from the book, it said to subtract an integer, add its opposite. Now, I added this right here, add its opposite or inverse. And the reason they're the same color is because those words go together. Opposite and inverse mean the same thing. Inverse is a very important mathematical term, especially when we get to our fourth unit on solving equations. That unit uses different types of inverse that help us solve equations. So if you know inverse means opposite, then when we get to those special inverse terms, you're going to have more of an idea of what we're going to be doing. Now, ladies and gentlemen, not a whole lot I can do with this. To subtract an integer, add its opposite. However, I am going to tell you how to add its opposite, because it doesn't tell you how to add its opposite in the book. It shows you in some of those examples, but it doesn't tell you. And I'm going to use a little catchphrase that some teachers don't like, but I just happen to use it because I think it works just fine. And that is same, change, change. So to subtract an integer, adding its opposite means we're going to same, change, change. Now, that really doesn't tell you much more right now. I get it. But when you see me do an example, and then we work through all the examples, you're going to go, oh, now it makes more sense. Please, please, please make sure that you are looking, listening, and learning first, and that you write down after I'm finished. And when I go to the next slide, then you'll know that it's okay to stop that video and write down that stuff before you move on. So we're going to subtract integers by adding its opposite or adding its inverse. How do we do that? Same, change, change. So let me show you real quick. Please look, listen, and learn. Here we go. Starting with this problem, 6 minus 9. Now, in elementary, your elementary teacher probably told you, hey, we always take the larger number and subtract the smaller number. You never subtract the larger number from the smaller number. Uh-oh, that's not the way it works anymore. Now that we're into our integers, we're not in our whole numbers anymore. We're in our integers. And in integers, you're allowed to do that. So here we go, 6 minus 9. So again, the first thing we do is we always look at that operation. And ding, 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 we are subtracting. So before I look at the signs, I've got to change that subtraction to adding the inverse or adding the opposite. And how do I do that? Same, change, change. So I write those letters underneath the parts of this problem. SCC for same, change, change. So here's what it means. It means that that six term is going to stay the same. That positive 6 is still a positive 6. And then I'm going to change from subtraction to addition because we're going to add the inverse. Now the inverse or opposite of that positive 9, the opposite is going to be now a negative 9 because in integers we have opposites, right? So now our problem becomes an addition problem, 6 plus a negative 9. And you know, as well as I do, that when we're adding and the signs are opposite, what are we going to do? Same signs add and keep, opposite signs subtract, or different signs subtract. So I recognize that 9 is the greater number, just as the number. We're not looking at the signs, we're just looking at the number. So 9 minus 6 is 3, and since that 9 is negative, we know that our answer is negative 3. On a number line, to model that, you could technically just start out at that 6, because that's the starting point. And then in subtraction, that negative sign, remember we're always going to the right. We're always going to the right unless we see a negative sign or a subtraction sign, because that tells us to change directions. So when we're changing directions, now I'm going to come up here and I'm going to subtract 9 by going the opposite direction, and I'm going to count back 1, 2, 3, 4, 5, 6, 7, 8, 9, and bingo, I'm at -3. When I change it to adding the -9, well, I'm still going to start at 6, but now I'm going to add a -9. Well, adding takes us to right, but then that negative before the 9 does what? That's right, reverses the direction on the number line. So again, we're just going to go back 9 until we get to -3. So we end up at the same spot. Ladies and gentlemen, I'm moving on to the next slide. Go ahead and write down anything you need before we move on. Alrighty, welcome to Subtracting Integers, example number 1. Now, ladies and gentlemen, I'm going to show you, this is what I want you to do when you're doing your assignments, because our assignments haven't been done very well. When we're subtracting integers or any other assignment that we're doing, any problem that we're doing, you always take it from the book and you write it into your paper. So in this first one, 8 minus 3, you would write 8 minus 3. And then we need to show our work. In other words, we're going to show our roadmap, show how we get from where we're starting, 8 minus 3, to our answer and how we got there. So, of course, the first thing we looked at, we're subtracting. Oh, wow, we need to add the inverse or add the opposite. How do we do that? Same, change, change. And so now 8 stays the same. Subtraction changes to addition, and that positive 3 becomes a -3. Outstanding. Then you look, I'm adding now. Woo! I'm adding. And I see that we have opposite or different signs. We have different signs, so I'm going to subtract. I see the 8 is bigger. 8 minus 3 is 5. And since 8 is positive, my answer is 5. Go ahead and copy that down and join me for example 2. In example 2, 9 minus 17. 9 minus 17, I recognize I'm subtracting. I need to change to adding the opposite or adding the inverse, as we like to say. And so we're going to take that 9 and it's going to stay the same. We're going to take that subtraction and make it addition. We're going to take that positive 17 and make it a -17. Adding the inverse. Now I recognize I am adding, and again, I'm adding different signs. Different signs mean subtract. I recognize that 17 is bigger. 17 minus 9 is 8. And since the 17 is the bigger number and it's negative, my answer is -8. Wow. Pretty straightforward, ladies and gentlemen. Go ahead and copy that down, and let's move on to the next example. -3 minus 3, and I recognize that many of you immediately in your head probably said -3 minus 3 is 0. Let's find out if that is true. So I recognize I'm subtracting. I need to add the opposite. I'm going to add the inverse. How do I do that? Same, change, change. So the -3 stays the same. The first term is now negative. It stays negative. It doesn't change. It stays the same. First term is always the same. And then that subtraction always changes to addition, because that's what we do when we subtract. We change to adding. What do we change to adding by? The opposite. That positive 3 becomes a -3. Now I recognize that I'm adding, and I'm adding two signs that are the same. Oh, same sign, add and keep. 3 and 3 is 6. Both signs are negative, so the answer happens to be negative. Go ahead and copy that down and get to the next example. Example number 4. Find -14 minus 9. So -14, I recognize I'm subtracting. What do I need to do? Change to adding the inverse. How do I do that? Same, change, change. So -14, the first term stays the same. Subtraction changes to addition, and positive 9 changes to -9. That is a positive 9. There's a subtraction sign there. And now I recognize I'm adding. Once again, I'm adding with the same sign, add and keep. 14 and 9 is 23. Both are negative, so the answer is negative. Next example. Example number 5. 9 minus a -8. So we start with 9 minus a -8. I recognize I am subtracting. What do I need to do? Change to adding the inverse or adding the opposite. How do I do that? Same, change, change. So the positive 9 stays positive 9. The subtraction changes to addition. The -8 now changes to a positive 8. I recognize that I am adding. I'm adding the same signs. 9 and 8 is 17. They're both positive. The answer is positive 17. One more example before our quick write. Negative 12 minus a negative 15. Negative 12 minus a negative 15. I recognize subtraction. I know I have to add the inverse or the opposite. And how do I do that? I same, change, change. To add the opposite, negative 12 stays the same. Oops, I'm not using the color I want to. Negative 12 stays the same. Subtraction becomes addition. That negative 15 becomes a positive 15. I recognize that I'm adding. Oh, we're going back to different signs. Different signs subtract. I recognize that 15 is bigger than 12. 15 minus 12 is 3. And since the 15 is bigger, the answer is 3. Ladies and gentlemen, if you just follow, you're going to get it. Alrighty. So our first quick write of the night. Write a complete sentence in your own words, how to subtract integers. You have 2 of those problems to do. Write them down, show your work, show your roadmap, take a quick break, and then come back and join us in a few minutes for our second video.